Hi everyone, good evening to all. Now we are going to study about question number 78, that is all about viscosity, especially terminal velocity. So what is viscosity? The very first thing. It's nothing but it's just like a friction in fluids. So between two solid surfaces, how friction will act? Same way, you have to imagine fluid as layers. Then frictional force, frictional or opposing force between layers is called viscosity or viscous force. So the nature of opposing the motion of one layer by the other layer or the behavior, like when you pour some water and oil on a floor, the oil moves slower than water. That means the force between the layers of the oil is more compared to the water. That means oil is more viscous than water. That is what the meaning. And between two layers, when you consider with a velocity gradient dv by dx with a surface area A, the viscous force is minus eta A dv by dx, and the tangential stress, sorry, eta equal to coefficient of viscosity, that is tangential stress per unit velocity gradient. So eta is called coefficient of viscosity, which depends on nature of the fluid or liquid. Now, usually they will ask question based on one important thing, that is Stokes law. That is, when there is a liquid and a spherical body dropped or thrown, then at any point when it is having velocity v, it experiences an upward force Fv. That Fv equal to 6 pi eta Rv, where R is radius, V is speed, eta is coefficient of viscosity. Now, actually when you consider there is a weight downward, there is a viscous force and there is a buoyancy also. So that the resultant force will become W minus Fv minus B. And here, as it is going inside, speed will change. So that viscous force will change, but W and B remains constant. So that the acceleration keep on changes. Now at an instant, when the weight is exactly equal to Fv plus B at a velocity, that is called terminal velocity. Terminal velocity means at that point, the resultant force will become zero, so that acceleration will become zero. And if you substitute the values, then Vt equal to, you will get the value like R 6 pi eta RVt equal to B minus W. B means buoyancy force. V sigma g minus V rho g equal to Vg, if you take common, sigma minus rho, or else you can take rho also common. Sorry, here I have taken small mistake. W minus B. So that this is rho, this is sigma, rho sigma. So when you take V rho g common, 1 minus sigma by rho. So mg into 1 minus sigma by rho. So that the terminal velocity formula will become mg by 6 pi eta r into 1 minus sigma by rho, or else if you substitute mass as volume into density, 2r square by 9 eta into rho minus sigma into g. So this is how the equation look like about the terminal velocity, based on which usually they ask question from the viscosity chapter, viscosity topic. So remember these formulas. And sometimes they will ask the question like in case of merging or dividing, when n drops merged, each of radius smaller, then n into 4 by 3 pi r cube equal to 4 by 3 pi r cube, where capital R is radius of big drop after merging. So that here n r cube equal to capital R cube, one relation will come. Then the terminal velocity, when you consider it, is r square, proportional to r square. So v for small by v for big one, what it will become is r by capital R whole square. So this way you need to solve the question when the question is given based on merging or dividing. In case of dividing also same thing. So they'll ask the question like comparison between the terminal velocity before or after merging or dividing, or between smaller and bigger one. Now let's see few questions based on whatever we have seen. The very first question is, a square plate of 0.1 meter side moves parallel to a second plate with a velocity of 0.1 meter per second. Both plates being immersed in water, if the viscous force is 0.002 Newton and the coefficient of viscosity is 0.01 poise, distance between the plates is. See, a square plate of 0.1 meter side moves parallel to a second plate with a velocity of 0.1 meter per second. Both plates being immersed in water. If the viscous force, what is the viscous force formula? Eta A dV by dx. Now velocity they have given as 0.1 meter per second. Now viscous force they have given as 0.002 Newton and the coefficient of viscosity is 0.01 poise. See, one actual unit is neta poise LE and poise is CGS unit. This is SI unit, this is CGS unit. And 1 poise LE equal to 10 poise. So now 1 poise means it will become 1 by 10 poise LE. And they are asking the distance between them means dx. So f equal to eta a v by x. So x equal to eta a v by f. So all the values are there. Eta area we have to find because square plate. So area will become how much? 0.1 into 0.1, side length 1. So 0.01 meter square. Now eta a v f, all the values are there. Then you can substitute and solve it. Now the next question is, with what terminal velocity will an air bubble 0.8 millimeter in diameter? So radius will become 0.4 millimeter. Nothing but 0.4 into 10 power minus 3 meter. Rise in a liquid of viscosity that is 0.15 Newton second per meter square. This only we called as Poise LE. And specific gravity. Specific gravity means density, relative density is 0.9. So that its density will become 0.9 gram per cc. So this is liquid density. So we have taken as sigma. Let's take it as sigma. And density of air. Okay, here one slight confusion is there, I'll tell you. Now understand the question properly. Our equation was terminal velocity Vt equal to 2r square by 9 eta into rho minus sigma into g, where sigma is the medium in which, density of the medium in which the drop was moving. Now here air bubble. Now it is moving in liquid. It is rising. So that here rho is 0.9 gram per cc. Because here it is not like solid in liquid. Here it is like liquid and gas combination. And it is moving in a medium of air whose density of air is 1.293. Sorry, again I have taken. See, this is sigma. Now sigma is the medium density. Now the medium is liquid, but the drop is not solid one. Here it is air. So what is the density of air? 1.293 kg per meter cube. So that is what? Because we have taken formula, when we have taken the formula, there solid was the one which is moving, having terminal velocity, sigma, rho, density. And sigma is the density of the medium in which it is traveling. Here the medium is liquid, same. Sigma is 0.9. But the one which is moving is not the solid one, that is air, gas one. So that's why rho is 1.293. So then you can understand and then you can substitute the values. So remaining R is given, eta is given, rho, sigma, g, everything is given. Just substitute and calculate the answer. See the same formula but they changed the slight different manner. So that is what you need to understand. Now here the question is, two spherical raindrops of equal size are falling vertically through air with a terminal velocity of 1 meter per second. What would be their terminal speed if these two drops were to coalesce to form a large spherical drop? Coalesce nothing but combining. So two drops means we have the general formula nr cube equal to capital R cube. So 2 R cube equal to capital R cube. Now, two spherical raindrops of equal size are falling vertically through air with a terminal velocity. Now, terminal velocity of small one is 1 meter per second. Now, terminal velocity of big drop they are asking. Big by small equal to capital R by small r whole square. Now, from here, 2 power 1 by 3 r equal to capital R. So, from here, capital R by small r equal to 2 power 1 by 3 whole power 2. So it will become 2 power 2 by 3. So what is the answer? VB equal to 2 power 2 by 3 times VS. So this way comparison based questions they can go. Now the terminal velocity V of a small steel ball of radius r falling under gravity through a column of viscous liquid depends on. So which are dimensionally correct. So Vt equal to mg by 6 pi r eta into rho minus 1 minus sigma by rho. This is the actual formula. Now Vt is proportional to mg by eta r. So we have already taken the formula. So the question is directly formula based, but they are asking the proportionality relation. Next, the ratio of terminal velocities of two drops of radius r. So it's a direct question, very simple question. When you remember the formula like this one, 2r square by 9 eta into rho minus sigma into g, then you will come to know that it is proportional to r square. Then v1 by v2 equal to r1 by r2 whole square, where r1 is r, r2 is r by 2 whole square, then it will become 4. So that way, the simple question or little difficult question or little calculated based question or little twisted questions. Anything can be asked, but most of the times the chances are there to ask question based on terminal velocity. So please remember the formula and try to understand the question, then you can solve it. So similar questions I have given as an assignment here. So please just try to understand and try to solve. One small thing actually, that is also important. So just I'll conclude it. When we drop a solid into liquid, then what can happen is the speed keep on increases and becomes constant. And that constant velocity is called terminal velocity. Or when we throw a solid sphere, then the speed means you have to throw with greater speed than terminal velocity. Then it keep on decreases and becomes constant. Then that is called terminal velocity. So when you give lesser speed more than terminal velocity, it keep on increases and becomes constant. If you give more than that, it keep on decreases and becomes constant. But at one particular instant, the velocity of the body inside the liquid becomes constant, and that we call it as terminal velocity. So in that way also you can say about the terminal velocity. So thank you all. We'll continue in the coming session with the next question. Thank you.